Hi everyone. Today we're going to study addition and subtraction of radicals. First, let us define like radicals. Like radicals are radical expressions with the same index and the same radicand. Example, 5 cube root of 7 and 4 cube root of 7. So we see here the radicands are both 7 and the indices are both 3. So these two radicals here are like radicals. Take note, we don't care about the numerical coefficients. Let's go now to addition and subtraction of radicals. As a rule, in adding or subtracting like radicals, add or subtract the numerical coefficients and copy the same radical. In symbol, we have the a nth root of x plus or minus b nth root of x. The answer here is the a plus or minus b, and then we affix the common radical, the nth root of x. Take note that when radicals are not like, it cannot be combined. Let's have example 1. The 5 cube root of 7 plus 4 cube root of 7. Let us check the radicand and the index. So the radicands are both 7 and the indices are both 3. So these two are like radicals. So we can now add the numerical coefficients 5 plus 4, and then the common radical is affixed here. Next, we're going to simplify now the 5 plus 4, it becomes 9 cube root of 7. So this is our final answer. Let's have the second example. Square root of 20 plus 3 square root of 5. We can see here that the radicands are not same. In here the radicand is 20, here the radical is 5, although the indices are both 2. Still, these radicals are not like. What we will do is to simplify the radical if possible. It means in the first radical here, we're going to remove a perfect n square factor. Then later on the simplified form, we will check again if this radical square root of 20 becomes like with the other radical. Now the 20 is now factored out into 4 times 5. So one factor is a perfect square, and that is the 4. And then we just copy the plus 3 square root of 5 here. Then we're going to show that this 4, the perfect square number, is equal to 2 square. Then we're going to distribute the radical sign to the 2 square and also to the 5. So we have here the square root of 2 square times the square root of 5, and then the plus 3 square root of 5 is copied down here. Next, we are going to cancel the radical sign and the power 2. Only the number 2 comes down here to be multiplied to this square root of 5. Then we'll just copy this 3 square root of 5 down here. Now we were able to simplify this square root of 20. Now becomes 2 square root of 5. So we can see that they are like terms now. It means we can now apply our rule in addition of like radicals. So we will add the numerical coefficients 2 plus the 3. Then we copy the common radical, the square root of 5. So simplifying further, the 2 plus 3 becomes 5. And then this square root of 5 is affixed again. So this is our final answer, 5 square root of 5. Example 3, the square root of 32x raised to 7 minus the square root of 50x cubed. Obviously, our radicals are not like. The radicands are not the same. So what we'll do is to simplify both radicals. We're going to factor out the radicands of each of these radicals. So we will be guided by this principle. For the number, one factor must be a perfect square. Since our index here is 2, so we're looking for a factor that is a perfect square. It means, in other problem, if your index is a cube root, you must look for a perfect cube factor. In the first radical, the number 32 is factored out into 16 and 2. For the variable x raised to 7, there is a clue here how to factor out that variable. It says one factor must have exponent of highest multiple of the index. Our index is 2. So the factors for x raised to 7 are x raised to 6 and x. For the second radical, the 50 is factored out into 25 and 2. We know that 25 is a perfect square number. For the x cubed, factors will be x square and x. And then we're going to show that this 16 is the same with 4 square. Then I copy the 2 here. For the x raised to 6, I'm going to represent this to be a value with power 2 because our index here is 2, but the value inside here must be x cubed. So checking here, if I multiply the 3 and the 2 powers, I will get back to that power 6. And then the x factor will just be copied down here. On the second radical, the 25 is now represented into 5 square, and the rest we just copy down here. The next line is we're going to distribute the radical sign to each of the factors inside the radical. In the first big radical, we have now this square root of 4 square, and then times the square root of 2 times the square root of the square of this x cubed times the square root of x. For the second radical, we have the square root of 5 square times the square root of 2 times the square root of x square times the square root of x. And then we're going to simplify further. In this first term here, I'm going to cancel the radical and the power 2. So you see, only the base form will come down here. The square root of 2, there is no change. I will copy here. For this expression, I will cancel the radical sign along with the power 2. Only x cubed will come down. For the square root of x, there is no change. Then minus. For the second group, for the first term, I'm going to cancel the radical sign with the power 2. Only the base 5 will come down. The square root of 2, we just copy down here. For this expression, I'm going to cancel the radical along with the power 2. Only the x comes down. And the square root of x, there is no change. I will copy down here. So the next step is we're going to multiply all terms with no radicals, and we will multiply terms with radicals. So the 4 will be multiplied to the x cubed, the square root of 2 times the square root of x. So we will have this 4x cubed square root of 2x. And then minus 5 times x will be 5x. And then the square root of 2 times the square root of x will be square root of 2x. Now on this line, we can now observe that we have like radical. It means we can now apply our rule of subtraction of like radicals. So we're going to add the coefficients of the radicals. In the first group, we have the 4x cubed as the coefficient, and then minus. In the second group, the coefficient of the radical is 5x. So we'll now put them together, the 4x cubed, and then minus the 5x. Then we will copy the radical, the square root of 2x. We cannot combine this 4x cubed minus 5x because they are not like terms. So we'll just keep it as it is. So this expression, the quantity 4x cubed minus 5x times the radical square root of 2x is the final answer. Hi everyone. Today we're going to study multiplication of radicals. First, let us have the product property of radicals. Suppose there are two radicals here, the nth root of A and the nth root of B. Take note that the index are the same. And n, and that is the index, is greater or equal to 2. And the index is also an integer. Then, if we multiply the nth root of A by the nth root of B, the answer will be the radical with the same n index with the product of A and the B. So you see here, the answer is the nth root of AB. This equation here is what we call the product property of radicals. Let us apply that principle for some examples. Let's have this example 1. Find the product of the cube root of 6 and the cube root of 2. The formula is here. As per the requirement, the index must be same. As you can see in this problem, the index are same and equal to 3. So what we'll do is simply take the radicands, the 6 and the 2, multiply them together, and the final answer is cube root of 12. Let's have example 2. Let us find the product of the first term 10 square root of 6 p cubed times 4 the square root of 3p. I put the formula here on this side, and there is a rule. We will multiply the numerical coefficients and multiply the radicals respectively. So in here I multiply the 10 and the 4, and that is 40. And for the radicals, I must check first if the index are same. So both are square roots, so we have the same index of 2. So we are to multiply now the radicands. So the 6 is multiplied to the 3 becomes 18. The p cubed times the p equals p raised to 4. So this is our answer. But I observe our radical here can still be simplified. So what we'll do, we're going to factor out 18 into two numbers such that one must be a perfect square. So that is 9 times 2. The number 9 is the perfect square number. For the p raised to 4, we're going to show that this is p squared and again squared. After that, we're going to distribute the radical to each of the terms inside the radical symbol. So we have now, first the 40 I copied here, times the square root of 9, times the square root of 2, times the square root of that p squared and again squared. The next is, we will show that 9 to be a 3 square value. And then, we are now to simplify further. I copy first the 40. On this term, I cancel the radical along with that power 2. So only the base 3 will come down. For the square root of 2, we simply copy here. For this term, we cancel the radical along with that power 2. So only the base p squared will come down here. So on this point, we're going to combine all terms that are not inside the radical symbol. So this 40 will multiply to 3, also multiply to the p squared. So it becomes 120 p squared, and also the square root of 2 will be copied here. So this is our final answer. Let's have example 3. There are two binomials with radicals that we will multiply. The first group is 3 square root of 2 minus the square root of 5. The second binomial, the square root of 2 plus 4 square root of 5. As per the rule, we will multiply each term of the multiplicand to each term of the multiplier. So the first group is the multiplicand, the second group is the multiplier. So if I'm going to take the first term, I'm going to multiply this to the two terms of the other group. After that, I will take this second term of the first group, then multiply to all the terms of the second group. So let's start with the first term. The 3 square root of 2 is multiplied to this square root of 2. We will get this 3 square root of 4. Next, the 3 square root of 2 times 4 square root of 5. We will get this 12 square root of 10. Now for the second term, I will multiply this negative square root of 5 to square root of 2. I will get this negative square root of 10. The negative square root of 5 times 4 square root of 5 will have this negative 4 square root of 25. Then let us simplify the first term. The square root of 4 will be 2. Later on, we will multiply to the 3. So the second term we copy also here, the third term also. For the fourth term, we can simplify this square root of 25 to be 5. Then later on, we will multiply to the number 4. On the next line, now is the product. The 3 times 2 is now showing as 6. Then for these two terms, they are like terms. They have the same radicals, same index, and also same radicand. So we can combine them. We will only combine the numerical coefficient. So this is positive 12 and this is negative 1. So it becomes positive 11. And then copy the same radical, square root of 10. Then minus the product of 4 times 5 is 20. And in here we can combine the 6 and the negative 20 to be negative 14. Then we will copy this radical down here, plus 11 square root of 10. So this is our final answer. Let's have example 4. This is now the square of the quantity 4 minus 2 square root of 5. We can expand this binomial here to be 4 minus 2 square root of 5 times 4 minus 2 square root of 5. And then we will do the long multiplication. Start with 4 times 4 is 16, and then 4 times negative 2 square root of 5, we will get this 8 square root of 5. Next, the negative 2 square root of 5 times 4, we will get this negative 8 square root of 5, and then negative 2 square root of 5 times negative 2 square root of 5, we will get this 4 square root of 25. And then we will simplify this square root of 25 to be 5. In the second term and the third term, we can see that they are the same radical. It means we have radicals of the same index and the same radicand. In that case, we can combine these two radicals in the middle. So in the third line, we have this 16 here, and then combining these two terms, we have this negative 16 square root of 5, and then plus the product of 4 and 5 is 20. So we can now add the 16 and the 20, it becomes 36. Then we simply copy this negative 16 square root of 5. So this is our final answer. There is another solution using a special product formula. So what I will do, I'm going to solve this same problem using the special product. First, I'm going to clear the board and then put the final answer on this side, the 36 minus 16 square root of 5. And I'm going to use the special product, the square of difference of two terms. In the answer, we will have three terms. So it means the x minus y quantity square is equal to these three terms, x square minus 2xy plus y square. So for the answer here, I am putting here three blanks to represent the three terms for the final answer. The first blank here is for this 4, I copied here and I put the power 2. Then for the second blank, I put these two terms here, the 4, and also this negative 2 square root of 5. So you see here the 2 square root of 5, the negative sign is already here. And then this number 2 here is a constant that we should always place. And the third blank is for this term negative 2 square root of 5, and we will put the power 2. So we were able to place all the necessary values. So we will now to simplify. The 4 squared becomes 16, and then minus. Then the product of these three terms, 2 times 4 times 2 square root of 5, we will get the 16 square root of 5. And then plus, we're going to square this term. Because of the square, the negative sign will go away. The 2 here becomes 4, and the square root of 5 is square. The radical sign is cancelled with the power 2, so we'll have the 5 only that will come here. Then we will simplify, the 16 comes down, then minus 16 square root of 5, multiplying 4 and 5 becomes 20. Then we will combine the 16 and 20. So this answer here is the same with our answer a while ago when we solved this using the long method of multiplication. Hi everyone, today we're going to study division of radicals. First, let us define the quotient property of radicals. Suppose I have two radicals here. The first one is the nth root of A, the second is the nth root of B. Take note that the index are same, and these two radicals are both real numbers. Another condition is that the B, this b is the radicand of the second radical here, should not be equal to 0. And for any integer n, and that is the index, should be greater or equal to 2. Then, if we're going to divide the nth root of a by the nth root of b, the answer will be a big radical here with index n. Inside the radical is a fraction with numerator a and denominator b. So this is the quotient property of radicals. Let's have some examples. Let us consider example 1. Square root of 15 over square root of 5. Obviously, our index are the same, so we can solve this problem using our quotient property. So this is equal to the big square root, and the fraction inside is 15 over 5. So we can now divide the 15 by 5. So the answer is the square root of 3. Let's have example 2. The square root of 48a raised to 7 divided by the square root of 3a. This is equal to the big square root, and the fraction inside is 48a raised to 7 over 3a. So we apply now the quotient property here. Next, inside the radical, we're going to group the coefficients and we're going to group the variable a respectively. We're going to simplify the 48 divided by 3. We will get 16. And the a raised to 7 divided by a, we can cancel that a in the denominator. We cancel the exponent 7. Then this will now be exponent 6. So in here, the answer will be the square root of 16a raised to 6. The next is the 16. We're going to show that this is equal to 4 squared. And then for the a raised to 6, we're going to represent this by a value with power 2. And inside the grouping symbol is a cubed. Next, we're going to distribute the square root into each of the factors here. So you see we have now the square root of 4 squared times the square root of the square of this a cubed. And then we can now cancel the square root and the square in this first factor. So only the number 4 will come in the final answer. Also with the second factor, we cancel the square root, also the power 2, only the a cubed will come down here. So the final answer is 4a cubed. Let's have example 3. We have here the cube root of 24x raised to 8, y raised to 4, all over the cube root of 81, x squared y. So we will apply our quotient property. So we're going to combine these two radicals into one big cube root. The numerator will be the 24x raised to 8 y to the 4th divided by 81x squared y. And then we're going to group the numbers together. We're going to group the x together, also the y's together. For the numbers, we're going to simplify this by factoring out a common number to the numerator 24 and to the denominator 81. So the 24 is now factored out into 8 times 3. The 81 is factored out into 27 times 3. For the x with power 8 in the numerator and power 2 in the denominator, we can show that this is x raised to the difference of 8 minus 2. And then times the variable y raised to 4 minus 1. So in here, the exponent is 4. In the denominator for the y, the exponent is 1. Next, we can now simplify our coefficients. We can now cancel the 3. So only the 8 over 27 will come down. For the x, we have the 8 minus 2. We have the power 6. So x raised to 6. For the y, we have 4 minus 1 power. So we have now the y cube. Of course, they are all inside this cube root. The next is we're going to group together this 8x to the 6th and to the y cube. Put them all in the numerator. The next step is we're now going to simplify by quotient property. It means we're going to distribute this radical sign, the cube root, into the numerator and in the denominator. And then we're going to use the product property to simplify by distributing the cube root to each of the factors. So we have the cube root of 8 times the cube root of x raised to 6 times the cube root of y cube. Then in the denominator, still our cube root of 27 is there. We're going to show this 8 to be 2 cubed. For the x raised to 6, we're going to show that to be a power of 3, and then the x squared will be inside this grouping symbol. So from here, we can now simplify. We can now cancel the radical and the powers respectively. So for the first term, we can cancel the radical with the power 3. So only the base 2 will come here. In the second term, we cancel the radical also with that power 3. Only the x squared will come here. On the third factor, we can cancel the radical, also that power 3. Only the y will come here. In the denominator, we can cancel the radical and also the power 3. Only the base 3 will come here. So for our final answer, this is 2x squared y all over 3. Thank you for watching. See you again next time.